So I think we finished the last part.
Oh, we just did the first part. We didn't finish
Yes,
the last
well,
part.
we did this part here. We ended here with part A. We didn't finish
Yeah.
part B and part C. Yes, so what we found the number of years to 18 years, 1.13 years as the reduced period here. Now we're trying to find the amount of the reduced final installment, the amount itself. So how do you find such an amount now in this case? So which means that the years now are reversed 18 years, right? If the years are 18 years, we assume that 18 full installments are made. And then the final installment is paid in year 19. So what we do is we find the present value of the 18 installments. So saying PV 18. PV 18. Present value of the 18 installments using the same concept that we used earlier on. So which is just going to be equal to 1,000, because the payments are equal, 1,000 multiplied by 1 minus 1.05. 1.05. The power negative 18, because look at 18 years only now, over 0.05. So let's patch this in, see what we get. So if you patch this in, so now I'm going to say 1.05, the power 18, power negative 18. 1 minus the answer, divided by 0.05, will give us 1,000 times 11.68959. Now times 1,000. This will give us 11,689.59 as the present value in year 18. So which means that the amount now is just going to be the original amount. Remember the original amount you had? The 12,033. So I'm saying the amount will be 12,033.56 minus 11,689.59. So saying 12,033.56 minus this will give us a difference of 343.97. 343.97 is the amount this is reducing by. 343.97 is the amount this is reducing by. So the amount payable in year 19 must now be discounted to what? Must now be discounted 19 years backwards. That discount this amount 19 years backwards. So already, this amount, right, is for the one that's here at this point. Time diagram, what is it? Okay, let's see the different time diagram I drew earlier on. It's the one at this point at year 0, at PV 0. So now, what are we doing here in this case now? I'm now saying this amount we found, 343.97, right? We're going to multiply it by the compounding factor. So multiplying this one by the compounding factor, which is 1.05, the power 18 years to find how much it's worth in year 19. So times 1.05, the power 18 years. So 343.97 times 1.05, the power 18 years. 343.97 times 1.05, the power 18. We're getting 827.80, 827.80, 827.80 as the amount of 0.88. Yes, 827.80 as the amount we are saving on in this case. So the amount reduced in final is 827.80 Are we okay here? Are we okay?
Okay, so maybe just try to explain. I was thinking that we went at 343, but again we've discounted it. So maybe just a further explanation on that.
Okay, so we haven't started with compounded. Keep in mind our time diagram, right? The PV18, the present value for 18 years, that one found, right? Is the one showing at this point at year 0. Where's that time diagram I drew before? See, it's the one showing at this point here at year 0. That 343.27 is the difference at year 0. But now, how much is that difference worth at year 18? So we're now going to move forward into time now, but traveling forward into time at year 18. So we're compounding in this case. We're now compounding into the future. Hence why we've multiplied by 1.05 to the power 18. Yes. Are we okay now?
Okay, it's great.
All right.
Okay, for me, I think I'm very much behind. Let's just go back to where you started from, answering the B part.
Okay, all right. Okay, doing that right now. So I started from here, right? Yeah. Okay, so we said we find the present value of these payments for 18 years, PV18. So we said the formula is the same now, like earlier on, right? So I'll say 1,000 times the annuity factor for 18 years. So which is this formula we're using here. 1 minus 1.0 to the power negative 18 over 0.05. This gave us 11,689.59, right? Now we subtract this from the principal amount we invested in, the 12,032.56. And the difference gave us 343.97. Now that 343.97 is the difference in year 0. In year 0. I want to find the impact
Okay, so you're saying,
on year 18. Yes. I'm saying this amount,
okay,
this amount here.
the 11,689, what we're finding
Is the
at the
present
present
value.
value of 18 years.
Yes. Since we're saying the time frame, the time period is no longer 20 years, it's 18 years now. So I'm now saying
Okay.
the difference between that, the difference now brings rise to a 343. That's the difference here. So that difference is what we're now going to find how much it's worth 18 years from now. So we actually know the impact it has, the significant impact it has at that point. Yes.
You know, Stephen, maybe just try to draw that line that you drew at first on this one so that you can demonstrate it. It came out very well on the other one.
Okay.
It will help.
Right. Okay. All right. 0. We have 10 here. We have 20 here. So this is our original timeline. This one. It's our original timeline, right? Here, our investment is worth 12,083.56 here. Subject to what? To 20 years. To 20 years. If we take it as 20 years, the present value is worth 12,083.56, right?
Yes.
If we take it at 20 years, at 20 years, now, we're told in the previous question we found that our timeline is now 18 years. So we reduced by almost 2 years here. So now we have to find the new present value, the new present value. So if we found what? So the present value all the way back side, we're getting the 11,689.59. Now, I see how these two are different here, right? So I'm trying to assess the impact of the difference, which we now say the 12 minus this here, which will give us the 343.97. But this 343.97 is the impact as at year 0, And we're trying to look at the impact in year 18. So we now move this amount all the way back to year 18. We're now transferring this amount to year 18. So we're compounding by 5% to year 18. Hence the move we have to put here, giving us this movement here. Now it gave us a final value of 827.80. Are we okay? Does that make sense?
Okay, for the time diagram, I've seen how we've drawn it, but I don't know why I'm making a mistake on the B part. Maybe just
Okay.
show the slide where it's starting. For the 1000 brackets, 1 minus. I don't know why I'm getting something very different.
Oh, okay, okay. Now the issue that comes up here, every time the issue that we have here is calculating here, right? So you always start
Yes, I don't know. The 1
Okay.
minus brackets 1.5
Okay, okay. I
divided
get
by
that.
0.05 to the power
All right.
negative 18. I'm not getting the 11.
Okay, no, I understand you. So we always start with this part first. Say 1.05, the power negative 18, then press equals. You've done that?
Okay.
Then say
Yes.
1 minus answer.
Okay.
Then divided by, the answer divided by 0.05.
Okay, it has given me the 11.6, whatever.
Exactly.
Even a calculator can tell you.
No, I understand you, I
Thank you.
understand you. All right, no problem. So let's move on. So now this is how we move with this here. Mr. Will, are we clear here? Mr. Soko, are we clear on this part? The time diagram.
Perfectly.
Mr. Wheeler,
Yes.
it now makes sense, right?
Yes, we'll try to master certain things that we can't understand.
No, the time
Yes,
diagram
we are
is not
master
really
students.
okay. The secret is time diagram, right? It just explains your timeline. You're not putting things into the real life perspective. Because remember, this course, after all, the course is called project finance. So you're assessing in terms of a project. If I build this at this point, if I get it done for this much time, how much am I saving? How much am I earning? Are you seeing how this is moving? So that's what I'm trying to assess here in general. Yes, that's how we tackle this question here. Now let's look at the next one, part C. Part C says calculate the reduction in total interest paid during the existence of the loan as a result of the interest rate not increasing. So this one, again, we're assessing the same impact. Now, if our original plan, right? Our original plan was 1,000 for 20 years, right? That was the original plan, 1,000 for 20 years. By 20 years, 1,000 by 20 years, not 1,000 by 20 years. So which means in total, the amount we're supposed to pay is 20,000 kwacha. In total, it's 20,000 kwacha. So much you're supposed to pay in terms of like value-wise, money wise, we're paying 20,000 kwacha, right? So which means the interest paid is now 20,000 minus the 12, 0, the original amount 33.56. This will give us 7,966.44 as a difference here. Now, the difference found here is not the full amount there. For 18 years, for the 18 years amount, right? 18 years amount, it's going to be 18 by 1,000, because that's the new term we're using now, which will give us 18,000, right? Now, 18,000 plus the reduced final payment we found. The reduced final payment we found, the 827 we found here, the 827 found here, plus the reduced final payment, so I'll say 18,000 plus 827.97 to give us 827.97. So the answer in B is what I'm using in C. Now, at that point now, which means the interest paid will now be what? The interest paid now. So this becomes the new loan amount, the new loan value. So which means interest paid in total will be 827.97 minus 1233.56, which will give us difference of 6,794.41. So this is going to give us the difference of this here. As now, that's the difference of the interest rate, right? The interest paid is that amount. So interest reduction now changes up, right? So imagine, initially we're supposed to pay this much interest. Initially, my first, we're supposed to pay this much interest. Initially, I0. Now our new interest is now, this is our I1. What we're actually paying interest rate. So the reduction now, reduction will be equal to the 796.44 minus 6794.41. So say 8966.44 minus also give us 11,072.03 as the amount we're saving interest terms. So we're saving 1,172.03. Gotcha. That's the reduction in interest rate, interest payments. Are we okay? Are we okay? Are we okay here, sir?
Yes, from my side.
Mr. Soko,
Yes.
are we okay? Mr. Soko, are we okay?
I'm okay now.
Mr. Soko, are we good?
Perfect.
Wonderful. So that concludes the end of question 5. I'll see you. Now let's look at question 6 now. Let's start with question 6. So question 6, we'll see how much we can cover in the time that we have. So I'll say the project gets a loan. Project gets a loan to be paid in installments annually in arrears. First installment is 50, second 48, and so on, with the payment reducing by 2 per annum until the end of the 15th year, after which there are no further payments. The rate of interest charged by the lender is 6% per annum effectively. Find the amount of the loan. Calculate the amount of the loan. Now this one is fun, right? We're looking at decreasing installments because the loan is repaid by 15 annual installments in arrears. 15 annual installments in arrears. So which means that the first one is 50, second 48, 46, 44, 42, 40, and so on and so forth. Effective interest rate is 6.5%. 6%. Now we're looking at what we're dealing with here is what we would call an arithmetic gradient repayment system. So the first
Are you writing? We're not able to see what you're writing. Okay.
Well, not yet. I'm saying our first A is 50. I'm looking at our arithmetic gradient repayment system, where the first installment is 50. Remember in our daily, back in our secondary, there was what you used to call nth term arithmetic progression, right? I always say nth term and so on. So in this case, I was saying 50, then 48, then 42, 46, then 44. So the common difference here is -2. So D here is -2. That's the common difference, -2, D. So until this is the end of it now. Interest is 6. Number of repayments, N, 15. I, of course, is 6% here. So this is what we're looking at now in this case, right? So we're trying to find the present value. So in this case, we try to use the formula for present value of arithmetic decreasing annuity. So I'm saying present value is equal to A times the arithmetic, okay, I'll just write the entire thing here. This is trying to write this in a way that's easy to understand. Okay. Times 1 plus b to the power n over I over I. Then this multiplied by this plus the common plus the difference, this plus G, and the common difference multiplied by 1 plus V to the power N over I minus N times V to the power N. And everything here over I. This is the present value for decreasing annuity. So now our payments are decreasing here. So I was trying to look at that point. Now, what is this V plus I over N? What's V to the power N? V to the power N in simple terms. V itself, V is simply V is equal to 1 plus I. That's V. V is 1 plus, it's 1 over 1 plus I. 1 over 1 plus I, that's V. 1 over 1 plus I, that's V. So using that concept, we now apply this here. So we can find this in advance. Let's find V in advance. We'll complicate our lives. Let's find V in advance. So let's find, so V is equal to 1 over 1 plus 0.6, which is 1.06. So 1 over 1.06 give us, so 1 divided by 1.06, or getting 0.9434. 0.9434 as V. So we know what to put on V here. So with that in mind, we then proceed. So I was saying this is going to be equal to A is what? 50 watch. 50 times 1 plus 0.9434 over 0.06. Now keep in mind the V is not just like that, it's to the power N. It's to the power N. Here it's minus, not plus, it's minus here. Minus, minus, minus. So here it's minus here. Minus. Then now times. The common difference is -2. D is -2. Let's reduce it. So -2 multiplied by what's inside here in the parentheses. So here, what's in the bracket here, we're saying the same scenario happens here. It's 1 minus 0.9434 over 0.06. Here it's supposed to be minus, here it's just minus, here not plus. Then now, everything that's here minus 15 times 0.9434 the power 15. Then all this over 0.06, which will give us 50 times, so 1 minus that, divided by 0.06. So we found this. The answer we're finding here is what I'm going to apply here. So here, I'm saying 1 minus 0.9. Sorry?
Excuse me.
Yes, sir.
Isn't it supposed to be to the power?
Where? Oh, here, right? Yes.
Yes.
The bar 15, sorry, my bad, my body. 15 and 15 here. Equals an error, sorry. So I say 0.9434 9434 to the power 15, then 1 minus the answer divided by 0.06. So the answer I'm finding here, that you want to apply here, the answer is the same here. The answers here are the same. So I'm saying 9.7118. Then times -2 by 9.7118 minus this side now. So saying 0.9434 the power 15, then 15 times 15 times 15 giving us, so 6 minus 6.2594 here. All this over 0.06. So I'm now saying 50 times 9.7118 times, now 9.7118 minus 6.2594 divided by 0.06. Whatever I'm looking for here will give us times -2 times 57.54 here. 7.54 here. Which is now going to give us here is supposed to be minus, not times, not minus here. So this is minus, not times. It's minus, minus. It's supposed to be plus. So since it's negative, it becomes minus. So now I'm saying 50 times 9.7118 will give us 485.59 minus 2 times 57.54 minus 115.08, which will give us 585.59 minus the answer will give us 370.51 as 370.51 as the present value of the loan, as the PV of this loan here. Are we okay here?
Okay, so maybe my follow-up question is, suppose it was increasing, were we going to use the same formula? And maybe where there's
Yes.
-2, we put the
Positive
+2.
2. Yes. Yes.
So this formula, maybe what is it called? Maybe we just need, because this formula was not given. So if one doesn't understand, it becomes a bit tricky.
Okay, it's called the present value of an arithmetic decrease. This one particular is for decreasing annuity. There's one for
Decreasing
increasing
annuity.
annuity. Yes. Yes, sir.
So it's the same decreasing and increasing. We use the same formula.
I think it's different for increasing, but for decreasing, this one use for decreasing annuity, use this one.
Okay, so
Yes. Yes, sir.
if I'm to use the present value method, can it equally work? Where I discount?
Which means you have to look at multiple discounting now, because you have to up until year 15. Up until year 15.
And the discount factor will be 6.
Yes.
Am I correct?
Yes. This comes out as 0.06. So it means you're going to discount from year 1 to year 15. So it's going to be like this. 15 here. And then so here, what we're doing in this case, right? Instead of us, because remember, year 0, year 1, in the beginning there was 50, then 48, and so on and so forth. So in the exam, we won't have time to start present value and everything like that. But if you feel like you have time and you're in safer bet than the formula, you can go for the other option. Or you keep present valuing slowly. Are we okay?
Okay, cool.
So until you reach where at 0? Where is it
I-
ending this one if we're at 3?
It's 15 years in total. So you have to write the numbers down: 50, 48, 46 until 0. Yes. Are we okay?
Yeah, we are good.
Okay. So let's reconvene later in the evening to finish up the remainder of the paper. Can now work on our part. Can that work on for us? So the link will be shared to you where the recordings have been posted. A link will be shared to you for each of the recordings from the one you had the other night up until tonight.
Do we have a recording? Do we have a recording for question 4?
Question 4, yes, I have it still. Yes. I'll upload everything this soon and then we'll share the folder for everything else. Then
Okay,
we're
that
going to
would
now
be
look
nice.
at yes, in the evening we'll solidify question 6. And then if you have any other questions regarding the rest, you can let me know, then we'll work on them. Are we
Question
okay?
4. Question 4.
Yeah,
Question 4.
Yes, no problem. All right. Okay.
Thank
All
you.
right, for now, we're going to wrap up here. Thank you. Have a good day.
What time is it in the evening? So that we plan
I think let's say 20.
20. Okay.
20 yes, 20 hours, yes. 20, 30, some other.
Okay,
Fair
thank you.
enough.
All right, thank you.